Hello everyone, welcome to this video. In today's session, we want to look at a question coming from Mathematics 2023, Paper 1, November. The topic, matrices. So here's the question. Given that matrix A is equal to 1, 2, 4, and matrix B is equal to 3, 0, 4, find part A, the transpose of a matrix, part B, AB. So before we could answer this question, let's just have some basic information about matrices. So if we have a matrix represented as matrix A equal to, we can just pick any numbers, 2, 1, 3, 1, 0, -2, like that. There are terms that you should be familiar with when it comes to matrices. Number one, we have something called rows. Number two, we have something called columns. So rows are horizontally, columns are vertical. So these which run horizontally are called rows. So we have one row and another row there. So for matrix A, we can conclude here and say it has two rows. So rows run horizontally, then columns should run vertically. So these are columns. These are rows. So rows, columns. So we have how many rows here? We have two rows. How many columns? 1, 2, 3. So we have 3 columns. We call this a 2 by 3 matrix. 2 by 3 matrix. The 2 stands for the number of rows the matrix has. The 3 stands for the number of columns. So this is a 2 by 3 matrix. So this is what we also call the order of a matrix. So the order of matrix A is 2 by 3, row by column. Apart from that, there's another term that you should be familiar with. We call this the transpose of a matrix. The transpose of a matrix. So the transpose of a matrix is a new matrix formed when we interchange the rows and the columns. So interchanging the rows and the columns forms a new matrix called transpose of that matrix. So if I have matrix A, then I want to find the transpose of matrix A. I represent this as A to the power T. So A with a T there on top is called the transpose of matrix A. How do we come up with the transpose of this matrix? Well, we simply interchange the rows and the columns. In other words, the rows should become the columns and the columns should become the rows. So this was a row. It should flip like that, becomes a column. So this is also a row, should flip like that. So I will start with this one, I flip it like that. So the numbers will now be 2, 1, 3. It's now a column. What happens to this? The exact same thing. So 1, 0, -2 should also flip like that. We're going to have 1, 0, -2. So this is now the transpose of matrix A. Sometimes we can actually give you the transpose of a matrix and ask you to go back to that. So if you want to find the transpose of a matrix, remember what you're just doing is interchanging the rows and the columns. So this was a row, column now. You can see it's now a column. This was also a row, it's now flipped like that. Now what happens if we give you the transpose already and we want to take you back to the original matrix? You just repeat the same procedure. Whatever is a row should become a column. Whatever is a row should become the column. Just do that. So if you want, you can simply say, oh, this is a row. It should become a column. So you're now going back to matrix A. This is a row, should become a column. This is also a row, should become a column. This another row should become a column, like that. Or you can just change this column, goes to a row. Change this column, this column goes to a row, just like that. That's how you find the transpose of a matrix. So with this information, let's see how we can apply it and solve those two other questions. So I give a matrix A and matrix B. Find the transpose of A. So part A, the transpose of A. So to remember, matrix A is 1, 2, 4. So to find A transpose written like that, this is very easy. All you just need to do is swap the rows and the columns. So we just want to interchange the rows and the columns. So we flip it like that. 1, 2, 4. And you get your 1 mark. Part B says find AB. So when we say find AB, we mean multiply matrix A and matrix B. So multiply matrix A and matrix B. So let's multiply those two matrices. The question is, how do we multiply matrices? How do we multiply matrices? The way you multiply matrices is by following a simple rule. We multiply these matrices by following this. You multiply one row by all the columns. So a single row should multiply all the columns found in that matrix. And as you multiply, you'll be adding the products. So it's row by column. So let's have this, let's keep this in mind. Row by column, that's how we multiply matrices. So let me write down the matrices we're multiplying. We have matrix A, 1, 2, 4. Matrix B, 3, 0, 4, like that. So before we could multiply those matrices, let's just figure out the order of these matrices. So what is the order of matrix A? So matrix A, the order of matrix A, we have one row by how many columns? 1, 2, 3. So the order is 1 by 3. How about matrix B? Matrix B, how many rows? 1, 2, 3. So we have 3 rows. By how many columns? We only have a single column for matrix B. So by 1, like that. The idea is when you're multiplying matrices, the rows of the next matrix, in this case, the rows of matrix B and the columns of matrix A should be the same. So you can see that here we have a 3 there and a 3 there. So these two matrices are compatible and can be multiplied. But the good news is that the examination body will give you matrices which are already compatible. So you don't need to carry out this procedure to find out whether or not they are compatible. So let's try and multiply now these two matrices. So we are finding AB. So A multiplied by B is equal to, so we substitute with A there. So we know that matrix A is 1, 2, 4. Let me just check this here. Multiplied by matrix B. So what's matrix B? We know that matrix B is here. So we have 3, 0, 4. Remember our guiding tool here is this one, row by column. Row by column. What do we mean? Each row, for this question, we only have one row there. So each row in here should multiply all the columns in there. And for this question, remember, we only have one row and one column. Then as we multiply, we need to be adding the products. So remember here, this matrix was 1 by 3. Then this one was 3 by 1. When you cancel out this and that, you're going to remain with a 1 there and a 1 there. Meaning the answer, the new matrix that you're going to find after multiplying these two should be 1 by 1. It's a 1 by 1 matrix. So one row and one column. So let's multiply. Remember, it's row by column. As you multiply, you'll be adding the products. So we're going to have, so you're going to multiply those which are corresponding. For example, 1 will correspond to the first one. 2 will also correspond to the second. 4 will correspond to the third. Just like that. So meaning you multiply 1 multiplied by 3. Then as you multiply a single row and a single column, you need to add the products. So plus 2 multiplied by 0 plus 4 multiplied by 4. Do we have any other row here? We don't have any other row. Do we have any other column? We don't have any other column. Meaning this will now give us our answer. So all we need to do here is simplify. So 1 by 3, that's 3, plus 2 times 0, that's 0, plus 4 by 4, that's 16, you can see that when we add 3 plus 0 is 3, plus 16, we are getting a single number, 19. So we're getting 19. So this is the answer. And you can clearly see that in this particular answer, we only have one row and one column, which was predicted by our guiding tool. This is how you multiply matrices. And this is the answer. Now, let me just do one quick example where the answer cannot come out as a 1 by 1. Let me just do a quick example to understand this. So suppose we have these matrices. We have matrix P equal to 2 and 0 there. Then we also have matrix Q, which is equal to negative 1, 0, 2, 1, 0, negative 3, 1, 2, 1, like that. Then we are asked to multiply these matrices. So if we are asked to find P, Q, what do we do in that in such a problem? So we know that when you're multiplying matrices, we need to multiply row by column, row by column. So how many rows do we have? Remember, PQ. So where there's P, I put P like that. 2, 4, 0. I need to separate this. Just so I can get rid of this. I'm multiplying this by matrix Q, negative 1, 0, 2, 1, 0, negative 3. Okay, let me just get rid of this part here so that the work can be much easier for us. So let's have a matrix which ends there. So we know that we have one row there. The idea is each row should multiply all the columns in there. As we multiply a column, we need to add the products. So it means that this row should multiply these two columns, like that. So we're going to start with this column. So we start with that column, we start multiplying. Remember, we need to multiply the ones corresponding. So 2 corresponds to negative 1. So it means 2 multiplied by negative 1, like that. Are you done? No. We go to 4. So, but what do? We add 4 multiplied by 0, like that. Then you go to this one. So what do? You need to add this. 0 multiplied by 2. So 0 multiplied by 2. So we are done multiplying this column. But do we have another column here? Yes, we do, this column. Meaning this row should also multiply that column. Remember, we don't need to put the multiplicants now down here. No, because this is occupying the top position and this other column is on the right. So all we need to do is leave a space and start multiplying on the other part there. So I have like that, then I just leave a space there, then do the same thing there. So 2 will multiply that. So it will be 2 multiplied by 1 plus 4 multiplied by 0 plus 0 multiplied by negative 3. Like that. If I had another column down, row down here, would have the bottom elements here. But in this case, all the elements will just be on top because we are dealing with a top row. So we continue. 2 times negative 1, that's negative 2, plus 4 multiplied by 0, we have a 0. Here, what do we get? We have a 0. Remember, there's a space there. So we have 2 plus 0 plus 0, like that. So if we simplify this, we're going to have negative 2 here. When we add this, we also have a 2 there. Please do not put a comma there because this is a matrix and not a point. So this would have been your answer. And that's how you multiply matrices. So see you. That's all for this video.